Welcome to Math 097 Lecture 26 from home. Today we're going to be talking about section 4.2, which is about graphing linear equations. Now, whenever you're thinking about a linear equation, you have to remember that the highest power of x is going to be 1, and the highest power of y is going to be 1. And once you realize that it's a linear equation, you know that the graph is going to be a straight line. Now, there are lots of different ways that you can draw a straight line. So what we're going to do today is talk about two of those techniques. So if you haven't already downloaded the lecture handout 26 yet, go ahead and do that now. Come back to the video, and then we'll go ahead and continue. So as you look at the handout, example 1 then is asking us to graph an equation by plotting points. And in example 1a, we're going to be looking at y equals negative 3x plus 1. So in order to graph this by plotting points, what we're going to do is create an xy table. So over on the right-hand side, you'll notice that I left some blank space for you. Go ahead and create that xy table over on the right-hand side. And then if you want to, you can go ahead and write down the equation for y. Y is equal to negative 3x plus 1 in that y column. And when you create an xy table like this, you get to choose the x, and then you calculate the y that goes with that. So let's go ahead and choose an x value that's relatively easy to work with. So I'm going to come in and choose an x value of negative 1. Now that I have that, then, I'm going to plug that negative 1 in everywhere that I see an x in my equation. So I have y equals negative 3 times x, but x this time is negative 1, plus 1. Well, negative 3 times negative 1 is going to be positive 3, and if I add 1 to that, I'm going to get 4. So what that means then is that we have the point negative 1, 4. Well, we have a Cartesian coordinate system on the handout for you, so go ahead and go to the x value of negative 1, y value of 4, and put the point negative 1, 4 there. So now that we have that point negative 1, 4, we need at least one more point to have a sense of what this straight line is going to look like. So again, it's a good idea to go ahead and choose an x value that is relatively small and relatively easy to work with. So let's choose an x value of 0 this time. Well, again, I can replace all my x's by 0. We get y equals negative 3 times 0 plus 1. Negative 3 times 0 is 0. Add 1 to that, and we're going to get 1. So now we have the point 0, 1. Well, 0, 1 is going to be right there. So the question at this point then is, do we have enough points? Ultimately, the answer is yes. However, your author really likes you to go ahead and calculate 3 points just to give you a chance then to check to make sure that nothing weird is happening on the other 2 points. So, okay, let's go ahead and go with the author on this one, and let's find another point on this graph. Again, I'm going to choose an x value, and I'm going to choose an x value that is, again, easy to play with. So let's go ahead and choose an x value of positive 1 this time. So we have y equals negative 3 times positive 1 plus 1. Negative 3 times 1 is going to be negative 3. Add 1 to that, and we're going to have negative 2. So now we have the point 1, negative 2. 1, negative 2 is going to be right there. Now the reason that the author likes you to have 3 points is so that you can look at your 3 points and check to see if they are collinear. If these 3 points line up, and they all line up on a nice straight line, that's an indication that things are going well. But if you find that one of your points is wildly out of whack from the other points, that's an indication that probably something went wrong with one of your calculations here. So if that's the case, if you find that one of your points is not lining up, you redo the calculation and see, oh, negative 3 times negative 1 is supposed to be 47 or whatever happened to be wrong, and then go forward from there. In this case, these 3 points are lining up, so I'm just going to move forward on this problem. So the last point on this particular problem then is to come in and draw the line. So draw the line that goes through all 3 of those points, and we have now graphed y equals negative 3x plus 1 by plotting points.